All right, well, let's get started. Let me grab you all the agenda. So this is technically the September call. So we still have another one coming in October. That's the link. So sorry for the rescheduling. Lots going on in the past month. So actually, to address that right off the top, because it's the first thing in the agenda. Apologies for delays, shuffling things around, being behind on specs, etc. It's been kind of an intense few weeks, in this economy, really. But that's all taken care of now. So, back into the spec mines, at least with me this week. So got a bunch of spec writing done yesterday. And actually the specs are in like reasonably good shape. Like they don't need massive overhauls, or at least the versions on ranches right now. And as hoped, they're not massively diverging from the 0.10 version to get to the 1.0. Right, so there's a couple changes, a couple tweaks, and one of the silver linings from various delays is it also gave time to hear from a few people about like, hey, I'm using it this way, I'm using it that way. I really care about this format. I really care about that format. Things like that. So, and that's actually brought a fair bit of clarity and sort of like an understanding of the various use cases. So as one example, the eternal JWT versus IPLD debate, continues to rage on, and people have very, very strong feelings about this on both sides. And I was chatting with some of the folks over at Blue Sky about this because historically they've been very, team JWT, and they've started using this stuff on the server only, and they're using DAG CBOR, so IPLD for a lot of stuff now. And as soon as they stopped using the front end, they stopped caring about JWT, which is interesting, which kind of revealed that there's these two audiences, right? Anybody doing stuff in the browser, they really care about this format. It's familiar, it doesn't scare people off, it helps them sell it to management. And then there's people who do things server to server who really care about shaving off bytes, right? When you approach projects, you always say, well, who's the audience for this? And I think what we've come to understand is that there's both. And because of the decentralized nature of what we're trying to do, and with all the partition tolerance and user agency and all these things, that's really driving a lot of the design decisions, all the way down to how we sign things, right? Using passkeys and whatnot. So that's actually been pretty clarifying, and getting some time with a few folks has been helpful with that, which also, as a side benefit, means that there's actually very little to change on those aspects in the specs. Library roadmap from my team's side. So I'll let Quinn talk about RS UCAN updates after I finish my giant list and rant. But good news. So as we always hope from a community effort, right, that there will be different teams will take on writing a bunch of code or writing specs and things over time. Web crypto API is a constrained environment. Yes, it is. Do you want to expand on that a little bit, Aaron?
Just that I found that on the server, you can basically make whatever you need to make work. The problem tends to come with there is a non-extractable key that's in a TPM that is only accessible through a web browser crypto API. And if you can't sign it using the things web crypto wants to do, my only choice is to give up on storing things in the TPM in websites and just stick a secret in local store and hope that's fine.
Yeah,
so you very quickly lose a lot of the hardware support you would like for a lot of your clients if you can't operate in that web crypto environment, whereas the server is just much more forgiving. I'm confident that I can keep a secret value on the server.
Yeah, totally. And hence support for things like RSA keys, right? side note, very exciting. EDDSA is now supported in, I believe, all browsers. We saw it in the release notes for Safari 17, really exciting, and mobile Safari. I haven't actually tried to do this in a mobile browser yet, but at least per the release notes, it sounds like that's either already landed or is about to. So maybe we can get rid of RSA finally. Yeah, so libraries, RSUCAN, Quinn's been putting a bunch of time into that, making that nice and robust. We're also in our roadmap going to be producing crates for a UCAN delegation store, revocation store, and invocation RPC, all in Rust, but with WASM as a second build target. So none of those things exist today. We know that we need them for our own use cases. And so obviously we do everything open source. We're going to release those into the community as well. If anybody wants to weigh in on how they've been doing those things, totally happy to hear about it as well. For probably the biggest change that we've been talking about internally for the 1.0 is moving the PRF, the proof field, out of delegations and over to invocation. And it's usually met with surprise at first, and then people go, oh, actually, that kind of makes some things easier. So this has been suggested over the past year by a few people. You know, Rackley and I've talked about it, Philip and I've talked about it. Basically, what it lets us do is make the exact network of delegations. We give it a very late binding. So basically, at invocation time, you can say, hey, here's the graph that I'm going to use. And you don't have to anticipate every possible delegation you need in advance. And it also opens up for people to experiment with things like saying, if any of these are invalid, invalidate the entire chain, right? And like you can start to, because it's now out of band, you can start to, you get a little bit more flexibility. It's not at write time, it's at verification time.
So Brooklyn, I don't understand a thing you just said about that. Can you put a link to where you have a write-up on that so I can try to understand it?
Sure. It's so in the PR, there's a little bit of writing, but maybe to do that at less than light speed. So in the existing format, there's a field proof in the delegation that links to all the other UCAN delegations that it's backed by. This means that you have to decide what those are at delegation time, and you may have more than one path through a network, right? Instead of having that field there, if we move it into the invocation token, then only when you go to use it, you have to say, it's actually this path that I'm using. Even though I might have several paths, I don't really care to give you all of them. I will just give you this one because this is the path that I'm using, you know, to close the loop.
But each delegation needs its own proof. Valid delegation.
Yeah, so there's still basically instead of hard coding it inside of the signature, it's still you still get a chain of proofs, but you don't sign over which proof you're using until you invoke.
I don't understand how that can possibly work. I need to see a write-up.
Okay, sure. Anyone else have thoughts about this? Should we spend time on this idea?
Just one aspect of that I found useful when we were chatting about it was the question of what to do when there's multiple paths through the proofs to prove the delegation. And I think the intuition click for me was when you might have different proof chains with different expiry times, and at the time of delegation, you may not know when that invocation is going to happen. And so you want to, at invocation time, be able to choose a proof chain that has not expired, is still valid based on that whole bag of proofs that you're aware of through all of the different DIDs that have like handled delegations for you. Sorry, that probably made less sense when I said it out loud.
Yeah. Like I said, I'm having built these systems, I just don't see how it would work, and I just need a write-up to help me understand it.
Yeah, maybe an analogy for people that have more of like an OCAP background. There's the whole OCAP serialization idea, where you can basically take some subgraph, serialize it, move it over the network, and then basically reify it on the other side. It's essentially doing that at serialization time, right, at invocation time, as opposed to all up front and only saying, hey, here's the only path you're allowed to use for this delegation. You can use, as long as you can create out of the separate edges in the graph, if you can connect them so that they give you the correct delegation and they're all signed over, then if the issue and audiences line up all the way and all of the attenuations line up, then you're good.
So it sounds like you've taken a linear problem and made it combinatoric to do the validation.
So the problem is right now it's combinatoric. So it actually, because we, for UX reasons, sign over multiple resources at a time. So again, putting things in browsers, we need to, for example, sign a bunch of resources with passkeys or with sign in with Ethereum or any of these systems. Asking the user to sign multiple times, 5, 6, 7 times, isn't a great experience, and people tend to work around it by just delegating everything. In fact, we already see that somewhat. So we're like, okay, cool, you can sign over this set of things. And now when you go to validate that, you already have this combinatoric problem. So we're actually giving people the ability to say, hey, you don't have to go against this entire giant list of like, well, maybe they're going to use this one, maybe they're going to use that one. We're going to say, you're invoking this thing, here's the exact path underneath that. You're invoking that thing, here's the exact path under that one. And so it actually makes the validation simpler than what we have today.
Okay, I'm drawing a blank. I just need to see a write-up. Let somebody else go.
Yeah, Rackley.
Yeah, I just wanted to point out one of the use cases that had been at least interesting from our angle, which is sometimes sometimes I want to redelegate everything from one device to the other, or not maybe everything, but big chunk of them. It is very convenient to be able to create a pass later on as opposed to ahead of time. And it is especially useful if some nodes in the pass got revoked, and then I want to kind of recreate that pass. By removing proofs from the signature, we basically can do that now, because I can create a pass after the fact and prove that there is a pass.
Yeah, no,
I
can see how it would be useful. I just can't see, I don't understand how it works. Can't understand how you can validate without seeing a write-up.
Yeah, so I think validation will still happen at the invocation. So at that point, you will have the pass provided for you. You just, when you delegate, you do not have to provide the pass.
Yeah, I've just done it completely differently. And like I say, I need to see a write-up so I can understand the flow.
Yeah, and there will be a formal write-up. I've already started the formal write-up on this in the UCAN working group / invocation in that PR. And I feel like I say this every month. I hope to have that out this week. But actually, like I am not jammed back to back with calls at present. So in theory, that'll happen.
Can you put something in the Discord when you do?
Sure. Yeah. I'll do that while Ugo says his thing.
Yeah, I probably also kind of need to see the write-up on this, because it seems like you inverting like almost the validation itself. So normally figuring out the path, it would be done on the validator side. Like you can just send the full store of delegations and hope that the validator goes through it all and finds one that it's valid. And now we would need to the invoker needs to provide just one that is valid. So it needs to resolve that path and send it to to whatever it needs to send or invoke. And on the other side, like when you're just delegating, you still need to send the proofs, right?
No,
So when
I see.
yeah,
Can I address the first thing, and maybe you can
Sure.
So I think you made the statement that validator needs to do the validation, and kind of whoever invokes doesn't need to do that. As we found on our side, that's not exactly true. It kind of you need to do it on both sides, because as you aggregate many proofs, you don't want to send everything at every single time. You kind of want to pick a pass and just ship that. So
Sure,
we
as an
already kind of do
optimization.
that on a
As an
yeah,
optimization,
but
right?
sure.
You can just send the full store of delegations that you have on your client agent, whatever, and just hope that one is valid, right?
Correct. So you could do the same thing in the future. You'll send the whole bag with the invocation and let the validator do the trying to figure out the path. Or you can optimize it further and do it only on it's still the same. It just with every delegation, you don't have to anticipate everything. You just do it at the invocation time.
Yeah, so it actually lets it be more concrete, because you're saying, I know this one got revoked. I don't need to provide these two possible paths for you. I know it's going to be exactly this. And oh, actually turns out that one was revoked. Cool, invocations are one off. You can reject that and I can try a different path, right? From the chat, Dijkstra's algorithm in the middle of verify, close, because we're making concrete the path at verification time. It's more like Dijkstra's algorithm or A star at invocation time. Like the writer has to provide the path. So you're right. So somebody has to do this, but we already had kind of that in verification in the current version, because now you have a whole graph and you have to find a path between the two. And we're saying, well, what if we actually narrowed that down and force people to give the exact thing?
Okay, I'm beginning to understand the disconnect now. The idea that when I do an invocation, there's a graph with multiple paths sounds to me like asking for a form of confused deputy, because
Yes.
the verifier might choose a path that I didn't intend to use.
Yes.
So already there's a problem. In the systems I built, there's only one chain, one link. There's no graph. I get a capability that's a part of a chain, and I can put another link on the chain, but it's linear always. Even though the proofs are there, it's always linear. There's no graph. A graph sounds really dangerous to me.
And so we're moving from graphs to a linear chain, except for when you need to join two. When you need to write amplification, right? Obviously, you're going to have two at that point.
But I have two chains. There's no link between them. Two independent chains.
Yep.
Right.
Yep.
Okay.
Totally. Yeah. And
what about the delegations, between two agents?
Yeah. When I delegate to you, I've got a chain. I've got my capability. I delegate to you. That adds a link on the chain, but it's still a chain, not a graph.
Right, but your two chains may share some early nodes.
Yeah.
Imagine I rotated my key
irrelevant.
3 times. I have key rotation, key rotation, key rotation,
Yeah.
Delegation.
It's irrelevant.
And the second one is key rotation, key rotation, key rotation, delegation. Like they've got the same first 3 nodes, but it doesn't matter.
Fine,
They're both just chains.
But it's irrelevant. You don't try to form a graph out of that. You just keep two chains. Maybe there's redundancy in it, so what?
Yeah, for sure. But as Brooklyn said in the beginning, you don't sign over it. So I don't know if I understand that bit completely.
So you sign over everything else in the payload, the thing that's being delegated, who it's going to, who you are, your DID, literally everything else. So each link, so if you think about, again, sorry, we're going to have to go to graphs here, right? Think about a graph. The principals, like the issue and audiences, are the nodes, and the edges are the delegation. You're giving one edge at a time and signing over that.
Right.
Okay. And that is secured cryptographically. And we're taking out, here's everything behind it, so that you can then construct that later.
So putting a link in rather than the full delegation chain, but the full delegation chain has to exist somewhere. and it has to be a chain, not a graph. That's fine. It's a form of shortening. Spooky did that.
Yes. Yeah.
Uh,
Yeah.
I-
And in a lot of ways, we're somewhat based on Spooky from early days. Sorry.
I think in simpler way to think about it maybe right now is basically it's like a chain right now, every single delegation. What we're saying, well, delegation is just a node, and when you invoke, then you assemble the chain as ship a chain.
Yeah,
Right.
we're changing who's responsible for creating the chain from an early binding to a late binding.
That's what I don't understand. That I have to see right now.
Sure. Yeah.
Charles has been waiting a long time.
Charles, sorry, you've had your hand up for a while.
That's good. Does it make it more difficult for someone who's verifying a set of delegations without an invocation that chooses any, like without an invocation that's kind of forcing you to choose a path? Could it make it more difficult to know if any of those delegations are actually not supported by any other delegations?
Yeah, so the downside here from a code and sort of like how do we get them across the wire now becomes the question, right? So we moved to content addressing already. Your proofs are already CIDs, so they're actually already decomposed, right? The only change now is taking that list of CIDs and pulling them out of one token. So you already had to pass along some sort of a set, right? So that you could have the table of CID to hash to UCAN. And so we have specs for doing this in web requests, and you can stick them in a car file, which I think is what Daghouse is doing, and all of these different things. And then the recipient needs to check on that. Hey, do I have a valid path? Like, is this a thing that I can actually use? One of the big advantages that we got and that we heard pretty loudly from some early users like UCAN 0.3 or so, who were trying it out at some larger companies, was that they liked the cacheability of having the hash, right? So like if they haven't heard about a revocation, they don't have to pass the entire chain every time. They're like, I know that this is the cryptographic hash. I already have it stored. I don't need to pass that around constantly, right? Or I don't have to have that sent to me constantly. And so when you write and so we've been thinking a little bit, about this library and whatnot, the delegation store is each UCAN that you receive, basically as it gets validated, gets added to this store and checks that it has all of it has at least one valid path behind it. And if something gets revoked, you obviously dump that into the revocation store, go into the delegation store and start marking things as invalid, right? And so it has this cascading effect, basically, right?
So you said one thing that I think you misspoke. You said set. It's really a list, an ordered list of, right?
Yeah.
Persistent order.
Because it has to
Yeah. Yes.
be, the proof has
Absolutely.
to follow the chain.
Yeah. So with the content address store, like just the way that we serialize it and pass it around, because the hashes today are embedded, just for thinking about it, right?
Yeah.
The hashes today are embedded in each token, and those are impossible to forge, right?
Yeah, no, but it's you said a set of CIDs. It's really a list of CIDs, an ordered list, because I have to follow from the root down to the end to do the validation.
Yeah,
The list is made by the UCAN.
Yeah.
The map could be just a map,
That's right.
but you get the list from going through the path.
Yeah.
Right.
Yeah, you reconstruct the list.
Okay.
I want to point out one thing that this might solve. We recently started finally working on the revocations on our end. And one of the challenge we kind of run into is, well, if some UCAN had been revoked, like, do we now try and verify through all kind of possible paths? Or like, it becomes a lot more difficult problem. And especially we would like to avoid going to a store and kind of keep checking back and forth all the time, right? So we found a valid path, something is bad there, then we have to go back, try different paths, then discover something is not involved there and like keep retrying. So that adds a lot of IO. If we switch to the invocation, giving the one linear pass, or maybe like 2 pass, whatever, at least 1 pass of validation, then we can just verify and either accept it or deny it. And that would simplify a lot of things on a validation part as well. So I am really loving this.
We only validate on invocation. And we only validate the submitted chain. So there's no graph, no alternate paths. And that
Yeah,
works
so right now
well.
it's not the case with UCANs, and that's kind of the part of the pain.
Okay.
Yeah.
That's something I missed in the spec.
Yeah. Quinn?
So that's actually more or less the same point I was going to make in response to Charles's question, that right now some of the UCAN libraries do validation of the proof chains when validating the token, but outside of invocation time. And I think that that's something that should really be avoided because of availability concerns around both revocation and the UCANs that are being used as part of the proof chains in the first place, because UCANs can only be really validated in that context with respect to a capability, an issuer, and some proof chain for that pair. And that's not always something that you can guarantee being available at the time of validation. Distinct from when you're invoking, different nodes may have access to different data stores that may be storing different UCANs and so on. And so I really do think that that's something that needs to happen at invocation in order to get really clean semantics.
Yeah, our users wanted to be able, when they got a delegation, validate that it was legal just as a performance optimization. Wasn't required. If you could do it, fine. If you got a wrong answer, you thought it was valid and it wasn't, you just get a rejection on invocation. So it was only there for an optimization.
I feel like there's kind of 3 types of validation that we care about when we're talking about UCANs. There's like the structural validation of, is this a well-formed UCAN? Is everything the correct types or the fields that we expect there? There's like cryptographically, does the signature actually match this payload? And then there's the invocation time, invocation or validation around the proof chains. And I think it's worth being really careful about when each of those steps happens.
Okay, that actually answers my question quite well. The way we've been approaching it has been, you give a delegation to a node and it basically validates everything, all 3 of those, and then sticks it into a SQL database just for easy querying of capabilities later when it receives anything that builds on top of that. And then we replicate some stuff to other nodes that might need to know. But that, okay, I wasn't thinking about the other situation where you might have all different availability concerns between nodes.
That's something that I've seen a few implementations do, and it's problematic in very subtle ways. For example, when you consider things like availability, I've seen a lot of perspectives on this where if you have some UCAN with some linked proofs and you can't resolve those proofs, it's not clear whether that means the UCAN is invalid or not. And when you're not talking about invocation, when you're just talking about the validity of the UCAN.
Okay, then we need to make it clearer in the spec, because the only way a UCAN is valid is if you have constructively in front of you the entire chain.
Well, I'm not talking about invocation. I'm talking about when you're just looking at like those structural and cryptographic checks on the signature of the like delegation. And if you perhaps as the optimization, as a performance optimization of not wanting to verify these chains when you have, say, a proxy passing UCANs through a system that may not have access to these stores to resolve all these proofs, but it still wants to do those other types of validation. Now you end up with like a non-monotonic verification where a UCAN whose proofs don't resolve may appear to be valid because you don't know whether the capabilities it claims actually have proof chains backing them up. But then in another context where those proofs do resolve, you can now like authoritatively say that this UCAN is not valid. but there you've kind of like flipped between like unknown to valid to not valid, and it's some subtlety that's a little finicky.
I think there's even more complications there that we kind of why we decide that we never mark UCANs as valid, and is because it can have multiple capabilities and proofs. It could be partially valid, like some paths are valid
Exactly.
and others are not.
Yeah, the sketch that I did for the delegation store breaks out each capability separately at the top level.
Once you have a revocation store, there is no real valid. It's invalid or maybe valid.
Well,
I mean, you could say I
So-
checked 1 millisecond ago, so
Yeah.
or expired,
unless it got revoked in the last millisecond, but
Yeah. the
but
recipient
also
of-
expired, right?
Yeah, the recipient of the delegation can only know definitively that it's not valid, can never know definitively that it's valid. But even that is a reasonable performance optimization if you're willing to do the work on the delegatee side. But the final check is at invocation, and that's the definitive one. And then it must know one way or the other.
Yes, exactly. Yeah. But yeah, it's a good point, Quinn, because usually when we've talked about this in the past, you're right that it's either about structural validation or like against a wall clock, or this sort of constructive version of, you know, your two answers are exists or I don't know, right? So we really have a 3-valued logic, basically. Yeah. Rackley?
Once we exhaust this subject or decide that we're done with it, I would like to maybe add one other item to discussion, which is revocations. As we've been implementing, we kind of feel like there's some shortcomings and maybe or something we could address. I don't know if it's good time now or not. But...
Great time. Let's talk about revocation.
Okay. Yeah, so one thing that we kind of end up deciding that we cannot go with the way it is spec'd out right now is basically revocation is its own thing. And if we get a revocation, but we don't have a UCAN that it's been revoking, do we just drop it? Or do we accept it? If we cannot verify, then maybe you are not able to revoke it. So that's no good either. So in a way, we have to like maybe queue it until we have a UCAN, and that complicates a lot of things. I think it would be fair and nice if revocation said, well, you need to give me the UCAN that you're revoking as well. Maybe I don't have it. That way I can verify that you are actually able to revoke it, and then I can mark it in my store saying that it's actually revoked. So that's one thing. And the other thing had been, we actually end up wrapping revocation block in the invocation UCAN revoke capability. And mostly that is, so we would like to be able to so if you try to revoke, and this is a scenario, we can verify it. We want to error and saying no, we didn't revoke that UCAN because either you are not allowed to revoke it, or maybe we don't have a UCAN, or there might be various reasons. So have this transactionality of you're letting us know that you're revoking, and we can tell you that it's not. Obviously, we could create whole another thing, but it seems like it would be nice if we can fit it with the invocation and receipt and all of this stuff, because then you have all of the things in place. And the third item, sorry, I'm gonna pile on the all the problems, and then we can talk about it. So for a long time, I was misunderstanding the spec in terms of revocations, and my assumption there was that only issuer of the UCAN can revoke it. Meaning I cannot reach few levels deep and revoke some things that so if I delegate to Brooklyn and Brooklyn delegated to say Hugo, I can't go and revoke the Brooklyn's delegation because I have not delegated it. And as it turns out, you could, but that's can of worms, because now one problem is I can revoke the delegation, but then Brooklyn can go and create another delegation to Hugo, the same one, essentially. And then that's no longer revoked. So I can do the whack-a-mole game here and trying to keep revoking, but that's not great. And I think real solution is I revoke Brooklyn's delegation. And then once Brooklyn sorts out the issue and revokes Hugo's delegation, then I can redelegate back and kind of recreate the paths. Especially if we do this invocation things, that becomes a lot easier. Then we don't have to reissue the whole chain. On the validator side, it becomes things a lot easier too, because now I have a chain I can validate. I don't have to kind of keep looking for a bunch of things.
Yeah, we've looked at doing only shallow revocation, and it has pretty significant UX downsides. If you revoke that first link and the person who's misbehaving is down quite some ways, and this person has delegated to 1,000 people, you've just revoked 1,001 people, right? Which is not great, you know. It's like inconvenience to the point of making the system unusable, right? You could talk to this one and say, hey, you own this linkage, you need to do this revocation. You're assuming that they're online, assuming that they're live, right? That they can actually do this. So it gets really tricky. I agree, actually, the making revocation an invocation totally makes sense. The original idea was to keep them as lightweight as possible so that they could be gossiped around, because they will sort of spread through the system. But honestly, I'm not against it. I think it's kind of elegant. It's nice. Let's do that.
Just a comment on that. There's arguments both for shallow and deep revocation. And so you could simply make it a policy of the verifier, which one it supports. And you don't have to architect it.
I think I would be more comfortable if we could say then, well, at the time of revocation, then give me the chain. Oh, hold on, actually, maybe not. I take it back. Let me ponder on this.
Yeah, we can take that offline. Philip?
I just want to point out a flaw in Irakli's example. So you were saying that you delegated something to Brooke, and Brooke delegated something to Hugo. And then you're revoking the delegation from Brooke to Hugo, right? And now it becomes a whack-a-mole game where Brooke is reissuing things to Hugo. But that is assuming that Brooke is the malicious actor here, not Hugo. Sometimes you have this case where Hugo is the malicious actor and you're trying to revoke Hugo and not Brooke. And so you want to reach down and revoke that. But then if it becomes a whack-a-mole game, of course you need to revoke Brooke, because now Brooke is being the malicious actor, right?
Yeah.
Exactly right.
That assumes the actual Brooke taking the part, right? When it's automated systems, things can get a little trickier too. But I think my main point was there that at the validation time, it becomes a lot more complicated problem, because I cannot just go through the chain and see. Now I have to, like, for every single node, I have to do all this kind of lookups.
Yeah, I agree. And I actually had my hand up before because, and I think you brought the point up while you were talking, because basically I think the revocation format just does not quite have enough information. It seems like revocation is like an invocation, which needs to be validated in a similar kind of way, where you need to have not really the capability, but something like that. You need to be in the chain of delegations upwards, right? So you have something to validate, sort of like in the invocations. And at the moment, the revocation format basically just contains the CID. And like back when, before all of these ideas of not having the PRF and basically not signing over the Merkle chain, you could perhaps fetch all of that. But now we need to go back and probably add some more info to it, so you can actually get back all of the UCANs involved in that and do a more exhaustive check.
Yeah.
On the point of like this redelegation, maybe like different way to solve it is not to say that I'm revoking Brooke's delegation, but saying the delegation that I gave to Brooke, I'm revoking her ability to redelegate to Hugo, right? That way, Brooke cannot possibly create new delegation.
Terrible idea. Terrible idea. Brooke will just share private keys.
Right. Okay.
Can't
Never
block
mind then.
delegation.
Yeah.
I wanted to point out that one other way to deal with this problem is to make revocation a specific permission and just include it in the scope or not.
Yeah,
And
we've
then
talked
all
about
these issues go away.
we've talked about doing that before. It's the concern is having irrevocable things. Like, you should probably want this to be default on,
Yeah.
in the same way that in, like, I understand that in like a traditional OCAP system, it's sometimes inconvenience to do
Yes.
that, but you always have the option to turn off a node.
Yeah, so
right?
in a
Yeah.
traditional OCAP system, you have to plan ahead, so you set up a proxy. The nice thing about certificates is you can do it all alone anytime you choose, and you don't have to anticipate. But yes, you can make it a specific permission, revoke, and whether it applies downstream or not is part of the scope of the permission. And then these issues become matters of policy, not architecture, and that's always a good trade-off.
Yeah, and you can have defaults, like by default, all of your descendants you can revoke, and things to the side you can't. But if I want to appoint a spam service to have the right to revoke people's keys, then I want to give that.
And then that
right
service
sideways.
isn't even in the chain; it just can revoke, even though it can't invoke.
How's that different than a delegation bit?
Can someone explain what this is about? I'm not sure I follow the.
Oh, so instead of having revocation be outside of the system, you just make it one of the permissions: read, write, revoke. And I can choose to delegate read and write and not revoke, right? And then I can revoke, but you can't. And I could hand off that permission to a third party, handle off just the revoke permission. And now I have someone who can revoke when I tell it to, but can't invoke the object. So it's a different way of doing it, and it might address some of these issues we're having with the delegate, revoking deep versus shallow revocation.
I'm not sure I understand how that solves the problem where we have a actor in between, and I want to revoke their ability to redelegate now. Or specific delegation, I guess.
Yeah, it can be done. It depends on how you interpret the revoke permission and what it applies to. So the revoke could be one hop only, could be the revoke permission could be any hops in the chain.
Yeah, so I guess where I'm getting lost, earlier you made a great comment that, like the revoking actor's ability to delegate to specific actor is not actually going to solve the problem, because you can create another actor and then that's it. Right now we have an even simpler solution from the malicious actor's perspective, because they can just create a new delegation to the same actor and suddenly your revocation no longer holds. I think, so my argument here is like, I think neither of them really work. Like, the solution here is to revoke whoever you delegate it to. And maybe there should be a separate protocol where you communicate with them saying, hey, either you revoke that other actor's delegations that you've created, or I'm going to revoke you.
It doesn't work.
Because at the end of the day, that's what you kind of want to happen, I think.
Now, Brooklyn hit the fallacy with that, which is the one you're telling to revoke is offline, and you need to revoke now. And that's a very common enterprise situation. So there are situations in which you only want shallow revocation, and situations in which you need deep revocation. And I believe that the best way to do that is leave it up to the validator. And now you don't have to architect. It's not part of the architecture. It's a policy decision.
Yeah, but
leave it up to the validator or leave it up to the delegator?
The validator.
Validator.
To decide whether whether the revocation was, if somebody does a revocation, when you validate, you decide if it was a valid revocation.
Yeah, like ultimately the validator gets to decide if it's going to apply a revocation or not, like in practice, right?
Right.
So I suppose, but how is that and I kind of like a bunch of us were talking at the same time. How is that different from like a delegation bit? Like we know that delegation bits tend to get ignored in practice, or people try to work around them at least.
What are delegation bits?
I delegate something to you, but I don't want you to be able to delegate it further. So
Oh,
I put delegation.
the do not delegate bit. That was in Spooky. Yeah. Bill France argued desperately to leave that out. The problem with that is people will then share credentials and you lose everything, all the trackability. People end up giving lots of permissions in order to delegate one. So you cannot prevent delegation in the presence of credential sharing. So that's right. There's nothing you can do about that.
Yeah, right. So, okay, so maybe slightly different then, yeah. Okay, I'll take my hands down now because this is the thing that I'd put myself in the queue for. And I just want to call this out because I think it went by really quickly. Using invocation for revocation is like, it is nice that we use the same mechanism, but it's almost, you have to special case the semantics, the delegation semantics for that now, because it works differently from anything else. You're no longer saying, hey, here's a closed loop. You're saying, I was somewhere in this chain and I want to revoke this thing, regardless if it's shallow or not, right? And you're talking about the certificate itself rather than the resource it's delegating. So it's a little bit like whether or not we implement it as an invocation or as its own thing, it has its own special case, which often for me implies that we probably want it to be its own formats, just to call out that it works differently. But yeah, I could be wrong.
That is that is exactly the issue.
I think you do specify the same chain though, right? Like if I were to invoke that, I would have to provide the exact same chain as if I'm revoking it.
Yeah, what it means is the chain becomes the resource that the revoke capability refers to. Just the way when you want to read an object, the object becomes the resource that the capability refers to. Now it's the chain, the delegation chain, that is the object, and that's the place where it's somewhat different than any other kind of resource, but it's only a little bit different.
Yeah. Okay. I guess what I'm interested in having ability to use a revocation and then fail that, saying no, you cannot revoke it, as opposed to just dropping it and not doing anything with it or using it.
And by the way, there's another issue in revocation, which is if I have a capability, am I allowed to revoke my own access to it? Am I allowed to revoke the capability delegated to me? And there are reasons to do that. Plausible deniability is one. I couldn't have done that because I revoked my permission.
Interesting.
Certainly seen systems in the past that play games like, oh, I would like to drop this permission. You are the last user with this permission. You may not drop this permission.
Yeah, in a certificate system, it's a little different because you're not normally garbage collecting that way.
Just a quick time check. We have 8 minutes left in the time slot, and then I know at least a few people on this call then disappear for our next call. Was there more on this topic? I think for a lot of this we can take it offline and move it into the discussion thread, or hey, we all know how to get a hold of each other in the Discord as well. So if we want to hop on another call later this week or something as well. Want to make sure that Quinn has some time to talk through some stuff from her UCAN fork, or if there's anything else that people have that's like a burning agenda item. So let's start with any final burning agenda items. Excellent. All right, Quinn, do you want to talk a little bit about some of the changes you've been making in UCAN?
Yeah, so I'll be pretty brief about it, but it's somewhere between a fork and a rewrite of UCAN that is meant to address some of the shortcomings that we've noticed in the library. So in particular, it's being built with portability in mind so that you can run it really easily, both on server deployments and as part of like WebAssembly in the browser, for example. but it's also being really careful around what sorts of really careful around how it allows you to define the resource delegation and attenuation semantics for different schemes, and is also meant to be really extensible around which like cryptographic algorithms it supports for signing, verification, and for DID methods. So it really leaned into the Rust crypto ecosystem here. They do some really great things around kind of separating like the specification of signatures from the implementation of how they are actually generated and verified. And so this opens the door for implementing like RSUCAN, for example, over abstract definitions of different signature types, but without prescribing the implementation of how to do that signing and verification. So that, for example, if you're dealing with ED25519 on a server, you can just use like a really performant, use the really performant DALEC implementation that's common in the Rust ecosystem. But then in a WebAssembly deployment, you would be able to use an async implementation over, they just have like an async signer trait that's actually designed for offloading signing to an HSM that ends up, if you squint, being sort of like offloading to the like browser TPM for web crypto, so you can deal with like non-extractable keys and so on. So really happy with how a lot of those cryptography changes have come about. Let's see, we have about 5 minutes. I don't know if I want to show too much code, but I'm just going to quickly share my screen for a second. So I wanted to be really flexible around how you extend like a UCAN deployment with different semantics for different resources and so on. So it has this little plugin architecture where you can define a plugin that defines its own resources, abilities, and caveats. This is just an example implementation of like the WinFS scheme, for example. You have parsers for how to parse the resources, how to parse the abilities, how to parse the caveats. And then this actually gets registered with the system. So there's 2 ways this happens. In server deployments or different environments where we have the necessary linker features, at compile time, this is actually going to be registered into the system so that you can now handle like WinFS plugins. That's not something that's possible inside WebAssembly because you don't have like run before main capabilities. But WebAssembly does expose, Rust WebAssembly does expose hooks for running code when the module is loaded. So you can then like dynamically register these plugins. But what this ends up meaning is that you can just add crates to your project that add semantics for like WinFS or the UCAN scheme or whatever it is that you're trying to interrupt with UCANs for. And then now the deserialization of UCANs is just going to kind of like transparently support those new semantics that you've added to your system. And behind the scenes, all of this is really designed to minimize the code size of the WebAssembly that's being emitted for the browser. So it's minimizing like monomorphization with generics, using like trait objects where possible to give us like better guarantees around how much flow up there's going to be when we actually do code generation. But it just ends up being relatively simple to define these like custom domain specific types for your semantics, define how they attenuate and delegate between each other. It's possible to define like cross-scheme semantics so that you can have a resource that can be an attenuation of a resource from another scheme. But just generally, I was trying to be very careful around how these plugins are written so that you avoid issues like rogue plugins emitting resources that they are not authorized to emit, with like, I don't know if they have like backdoors in them to support granting capabilities that they are not the owners of and so on. Really just trying to tackle a lot of the ergonomics issues that I and other people have mentioned with some of the existing implementations. Sorry, Rackley, you have a question?
Yeah, I'm really curious if you something in this? Because like I've been contemplating similar problems in JS, however. On like who is the owner of a resource, meaning who can create the first delegation. And I kind of end up deciding that I don't have a solution. So if it's your deeds, then you are, and if it's not your deeds, then you aren't. Everything else is not easy to prove. So I was wondering if you have any thoughts or solutions for this kind of problem.
I see Brooke has her hand up. My instinct is that there's not a way to solve that at this level, and that's something that kind of happens outside of code, but I'll let Brooke take that.
Yeah, so we're moving as much as humanly possible to the mechanism that you're describing, where you have this closed loop on the did, right? And every resource gets its own. So even CRDTs, like WinFS, gets its own did that it initially delegates. You know, hey, I came online. You're my caller. You're my parent. Here you go. Here's a delegation to me, right? And that's great. And that they become, as I think you've called them before, like self-verifying, right? And I think that is the best practice, the right way to go. All of the literature supports it. It's correct. The hard
and by
part
did you mean did key, right?
Did key, yeah. Well, I mean, the spec is open about that, but yes, did key is self-verifying, right? Or did PKH, you know, right? Any self-verifying method. The hard part is when you want to interact with things that are outside of this system, at which point now the validator needs to understand that last step, right? So we're trying to avoid that as much as possible, but we still also need to be interoperable with the outside world, right? So that becomes a validator's problem, and you can't self-verify that. You can get a closed loop on who claims to own it, but you can't guarantee that they actually own it, right? So like send an email. I can't guarantee you that they have control over that email unless I give you a DKIM signature, but who knows, right?
So somewhat solutions that we've been kind of gravitating towards, and I'm not sure we will end up doing, but because of the TLS certificates, like whoever owns a domain are basically the owner, and they, in theory, could delegate sub-URLs. So that is kind of what we're thinking to do, and deed web actually allows to bridge us that, right? So if you have a deed web URL for that domain, then technically you're able to delegate. So we can create this like root authority.
Sure. Let's say, as an example, I want to wrap MailChimp. MailChimp isn't going to expose a did anytime soon. So I can have a agent like a did that claims to have access to this account, but I can't guarantee it, right?
Yeah, so it's a separate domain that you have no control of, then obviously you can't.
Yeah. So in those cases, you have to wait for the validator to be like, yep, they can actually do this or not. And so you're pretty sure, or at least you can validate the claim, like that the chain is correct, that it is structurally accurate, but not that they can actually do those things, right? Which I think is always the case, but it's...
So how do you do that? You just leave a hook for an oracle that says, if you have this question, ask this oracle, and it will say yes or no?
Yep. Yeah, exactly.
Yeah. So what we're trying to do is somewhat slightly different from that, which is, if Oracle can say that it is, can Oracle issue the attestation and include that in a proof chain? That way I don't have to go and ask Oracle. Oracle certified it ahead of time.
Yeah, and like I agree whenever possible, and I would really like us to get to the point where we have, you know, even better than DKIM, we have DMARC and we have DNSSEC certificates and all of this stuff. But I think there will always be cases, and even when you claim to be the resource yourself, there are already cases where as soon as you have something that's effectful, you already don't have a guarantee that it can do that. You have a promise, but not a guarantee, right? It's just a claim.
So one thing that may be worth pointing out, like the email situation that you were describing, I've been thinking about the two, but at the end of the day, if I want to send emails through that email address, I cannot just do it. I have to go and tell the service endpoint saying, hey, I have this permission, send it. So maybe resource doesn't have to be an email. It could be like domain/email, which then they can delegate to you and they act as a proxy essentially. But I feel like that is, then you get this nice benefits, right? Like, sure, the resource looks kind of funky and you do the mapping, but at least it's all in place. Anyway, but I think I derailed the whole thing, so I should let Quinn continue.
And we're over time, and a few of us have a next meeting. Quinn, was there anything you wanted to wrap up with? Just
Yeah, I think
last 30
the
seconds?
most relevant thing to most of you here is that in this, I've been working with Brian a little bit. He put together a big suite of conformance tests for UCAN. So some of these are here, but they test things like verification, whether you can properly build UCANs. We're working on additional tests for like how proof search needs to look and so on. And I am building for these tests with this rewrite. So when we get these to a good state, hopefully those should be able to help out all the implementations just stay in sync with each other. And on the cryptography side, just one of the other big focuses has just been making it so that the library itself handles all of those like nitty-gritty concerns, like ensuring that memory is always zeroed and things like that. Just trying to offload all of that stuff from consumers of the library and get it kind of baked in as deep as possible so it's all misuse resistant.
Any chance that the conformance test vectors could be like its own repo thing so we can easily pull them in? And
so it is. I can grab the link for that for you. I will say there's issues with the existing tests that are not captured in this pull request, but Brian has been opening issues on the repo as I point those out.
And I also want to call out really quickly as a final thing in RSUCAN. So some of the thing about registering plugins, like all of that extra stuff for anybody who's familiar with Rust, it's sort of like, oh, why aren't you using some of the built-in mechanisms? And the big reason is we want this to be callable from JS and adaptable from JS as well when using WASM. So there's a lot of stuff in there to make this very reusable in browsers, as you know, as Quinn was saying, as well as on servers. Okay, cool. At least I need to run, and Quinn needs to run, and the Fission people need to get out of here. Thank you, everyone, for the conversation. Ellen, you have my email address now. I just sent you an email earlier. Anybody who has follow-ups, we can take those into the UCAN Discord, and I'll see you all in a couple weeks.
Thank you.